How diagenesis can be useful in sequence stratigraphy is a big subject. The summary we can discuss here. Sequence stratigraphy enables us to predict the distribution of mudstones or the fine grained deposits. These can act as seal, can give rise to hydrocarbon reservoir, and that is why sequence stratigraphy is so much important in hydrocarbon geoscience. Sequence stratigraphy is important in hydrocarbon geoscience. Now, from sequence stratigraphy studies, by doing this study one cannot understand the diagenesis. Rather, the process of understanding is from diagenetic studies and from several other inputs we come to the sequence stratigraphic model, and this is said here. Carbonate sediments are more reactive with sea level changes in terms of the pore fluids than the siliciclastic deposits. Diagenetic alteration of carbonates can more readily be linked to the sequence stratigraphic framework than the siliciclastic materials. Diagenesis is also important because in sequence stratigraphic studies, diagenetic clay minerals are reliable tools to identifying systems tracts. Let us look at the sequence stratigraphy in terms of progradation, retrogradation and aggradation, and how the different surfaces can be identified using sedimentology and other knowledges. Let us understand the transgressive surface first. TS, here it is stated, and this is where the surface lies. This transgressive surface can be composed of algal bored and encrusted intrabasinal fragments derived from marine erosion of sediments. This can include paleosols, calcrete, bioclasts, high stand mudstones, sometimes siliciclastic sediments followed by carbonates found at TS. Let us look at MFS, maximum flooding surface. It represents a condensed section. Condensed section means a hiatus surface. Let us understand first of all what is the meaning of condensed section, then we will come back to the maximum flooding surface. A condensed section is a conformable succession that accumulates low rates, therefore condensing time within the stratigraphic section. This can be a depositional surface where the sediments coming from the water above is low in amount and the rate of sedimentation here is low. So, this much thin sediment can indicate a long geological time span, a rather long geological time span indicated by a thinner sediment deposit. This is the meaning of the word condensing time, as if very long geological time is condensed within this thinner sediment deposit. These are typical products of pelagic or hemipelagic sedimentation during transgression, and they can host many microfossils, orthogenic minerals and organic matters. Now come to MFS here, maximum flooding surface. Where is it located? This green line which I am highlighting is the maximum flooding surface. So, this is a place where time is condensed because sedimentation rate was low during transgression and when flooding was happening, that means water level was rising. There can be good amount of microfossils found at this horizon. What are the minerals that can be found? We can find glaucony. Glaucony is an orthogenic mineral that occur in both ancient and recent marine deposits. The MFS that I am showing here can be of very old rock or a relatively younger rock, be it very ancient or be it very recent. Glaucony is found at that spot. It is a good indicator of low sedimentation rate in marine deposition and it is a reliable stratigraphic marker. Further, to explain about glaucony, it is a depositional facies consisting of sand sized green glauconitic grains which is green mica. So, we have defined the transgressive surface and the MFS. We are going to see now this portion of the curve given by TST, transgressive systems tract, and this green color represents that kind of rock. What kind of rock are they? They are the shallow marine sandstones and mudstones. Peat can develop during transgression of coastal plain under humid climate in both siliciclastic and carbonate successions. It can be a siliciclastic succession, it can be a carbonate succession, but in both the cases peat can develop, which is a low rank coal. So, in this way the TST can be identified that it is a shallow marine sandstone and it can be mudstone. There may or may not be peat developed along with it. In these diagrams, coal or peat formation is presented within the sequence stratigraphic framework. Here we are taking coastal and shallow marine deposits where LST, TST, MFS, HST, SB are presented, and in this case coal is found in contact with MFS. And we can see in this diagram that the TST is in contact with the MFS. In other words, one of the boundaries of TST is the MFS. This diagram presents how, in what way the lateral extent and thickness of coal seams depend on the rate of change on the base level or with the rate of sea level change. For example, if we follow this curve showing the rate of change of the base level, then within this domain we get moderately thick and continuous coal deposit shown by these two figures. As we move to this domain, or after going up and then coming down in this domain, we get very thick and isolated coal bodies, and within this part we get coal which is thin and discontinuous. So, the thickness of the coal unit and the continuity or the discontinuity of the coal body is related with the rate of change of the base level. We have already covered transgressive surface TS and the maximum flooding surface MFS. More information about them, that these are the sites of porosity destruction in sandstones and carbonate successions due to extensive carbonate cementation. MFS shown by this green line and the TS shown by this line, these are the zones where there is porosity reduction within the sandstone and also within the carbonate, and it happens due to carbonate cementation. This is typical of TS and MFS. Now, let us look at FRWST. This is FRWST, also is same as FSST. FSST is the falling state systems tract. What is so typical at FSST is that we have sharp base sandstones deposited in shore face environment above erosional surface formed during regression. Let us look at FRWST within the diagram. This is the color used for the FRWST or the FSST, and it can be seen here. This is the place we expect sharp base sandstone deposited in shore face environment above the erosional surface formed during the regression phase. This is the deposition that happened during the regression period. This is the diagram, this is the graph showing within the curve the regression portion. Let us look at the sequence boundary SB. SB is located here given by the red color. This is the place of abundant locally reworked glaucony in paralic and deep marine sand deposit. Glaucony I have already explained. Paralic means transition marine non-marine environment. What happened when this line was developed in the section? This was a time when abundant locally reworked glaucony in paralic and deep marine sand deposits developed. So, these are the typical way to identify the SB, FRWST, TS and MFS and TST. However, note whatever I have stated here is a general statement, and each and every sequence stratigraphic section may not follow these things. In one of the previous discussions, I have referred karstification, that the carbonate deposit get exposed to atmosphere due to regression, and this is the time when porosity of the carbonates increase and this enhances the reservoir quality. So, in this presentation there are hints of why the sequence stratigraphy can be important. Increasing reservoir quality can develop during karstification. Secondly, I have referred peat and coal formation in the context of TST. How the relative sea level rise and fall can be expressed with sinuous curve I have already presented. Here are few more important points. Consider for this curve, this is the time, that is a Younging direction. If the curve goes this side, that means there is sea level rise, and if it goes in this side, that means there is a sea level fall. So, from here to here when you are going means that sea level is rising, which means base level is rising. If the curve goes in this direction, in this portion, this is the base level fall or negative. When at this point or at this point the water level is high, deeper marine condition can exist at some specific location. Therefore, this can be a place of mud deposition. That is why in this direction which is stated as mud plus, and when the curve goes down such as in this way, say from here to there is a less chance of mud deposition because the water depth is decreasing. Rather, this would be FR is the forced regressive deposit, and there are two parts one can define: early FR and late FR. HNR is the high stand normal regressive deposit. LNR is the low stand normal regressive deposit. T is the transgressive deposit, which can be divided into an early part and a late part. HNR was here and also it comes over there. CC is the correlative conformity and it is mappable, important. Again CC comes here. In the graph, if we look at points across which the curve changes its pattern from sea level rise to sea level fall, the corresponding point is marked as CC star or the correlative conformity. And here also, where in this crystal point where the curve changes its effective is geological outcome from a sea level fall to a sea level rise, is also marked as CC star. This CC double star is as per one author and this is a CC star as per another author. MRS is the maximum regressive surface, which can be cryptic. MFS is the maximum flooding surface, important, this is mappable. So, what are the things that are mappable here? CC star, CC double star and MFS are mappable. In other words, writing in full form, the correlative conformity and the maximum flooding surface are mappable. Different kinds of deposit patterns can also be linked along with this curve. For example, the mud flow deposits can develop here marked by 1, that means within the early phase of FR. Within EFR we can have mud flow deposits and dominated by lobes. Second, the high density turbidites marked by 0.2 is possible to develop within the late FR. So, clearly EFR and LFR can also be discriminated based on the kind of sedimentary deposit. The low density turbidites dominated by channels can be found here marked by 3, and it occurs from LNR up to the early T. LNR to early T is characterized by low density turbidites. Condensation can be found in these two places, that means HNR is characterized by condensation. The major diagenetic processes and products related to sequence stratigraphy in the siliciclastic deposits has been tabulated here by Morad et al. 2012. Whenever in the sequence stratigraphic framework there is clay infiltration or clay is transformed to elitization, in these two cases permeability falls. If the infiltrated clay becomes chlorite, in that case the porosity is preserved. In any case of grain dissolution and kaolinitization, porosity and permeability increases. This is also a case of karstification. When karst forms, porosity increases. It is a common sense matter to understand that whenever there is cementation, porosity permeability are going to fall, be it siderite cementation, be it carbonate cementation, and similarly be it compaction of the sediments where grains come closer to each other, porosity permeability are to reduce. In case of high stand systems tract, common sense says that whenever there is a cementation, porosity permeability will be reduced, and in case of a dissolution there will be enhancement of porosity and permeability. In this way you can watch what are the situations when dissolution happens, what are the situations when cementation happens, or if any chemical transformation happens. In those cases accordingly you can understand where the porosity will increase, decrease or remain the same. The three processes that have been described in this table, cementation, dissolution and clay mineral formation. How the shifts happen during the distribution of meteoric, mixing zone and marine zones in platforms and in ramp setting during sea level rise and fall has been summarized in this diagram. When there is a sea level fall, this portion is exposed to atmosphere, trees can grow, rains can fall, but when there is a sea level rise, this portion gets submerged in water, and the marine zone, the groundwater zone which is affected by the marine water intrusion moves inside and it comes here. So, the previous mixing zone is pushed towards the landward direction, it comes here. A similar thing is observed when we take the ramp geometry of the continental landmass. This is a marine zone, this is a mixing zone, and then this portion was exposed to atmosphere. So, trees have developed, rains can fall. Now, the sea level has moved up. So, there is a landward migration of the mixing and marine zones. Mixing zone has moved in this way, meteoric zone has also gone in that direction. Let us understand when carbonate cementation takes place in the sequence stratigraphic framework. Consider clastic sediments to be deposited as over here. Say this is the sea water level. Now consider there is a flooding surface development, which means that the water level has increased. In that case, the final product will be concretions developed above the shore face sediment, and over that pro delta sediments can be found. Whereas in case of a normal regression, this water depth has reduced to this much. The shore face sediment thickness has increased, here it is this much depending on the sediment supply, but the point is no concretion developed over here. Important point. The diagenetic processes related to sequence stratigraphy in case of carbonate deposits can now be looked at. Whenever there is dissolution and karstification, that means karst terrain form, there will be enhancement of porosity and permeability. And as usual, whenever there is a cementation, there will be reduction of porosity and permeability. Both these processes take place in subaerial condition. Pedogenesis or soil formation reduces porosity and permeability. Genesis of kaolinite and bauxite. Kaolinite is a clay mineral. Kaolinite and bauxite, when they are formed, they can little bit reduce the porosity and permeability. If by evaporation dolomite is produced, intercrystalline porosity can be generated. If cementation of any material happens, and in this case say of aragonite, there will be reduction of permeability. Same point for the high stand systems tract, aragonite cementation will lead to permeability and porosity reduction. Cementation once again will lead to decrease in permeability and porosity. It does not matter where cementation happens, whether in the TST or in the HST. Common sense says that whenever there is a cementation, there will be porosity and permeability reduction. Many of the sequence stratigraphic diagrams that I have shown are structurally undisturbed, which is not the case worldwide. This is just an example. There are many other examples available. This one shows that suppose there is a reverse faulting along this line, as if this block moves up and that block goes down. In that case, the sequence stratigraphic units naturally will get faulted. So, do not always expect this kind of sequence stratigraphic situations in the real world. Consider a case that in shore area there has been an extensional tectonics that has deformed the continental crust. It has produced graben and horst. So, in this part a push will happen, so that this portion of the topography will move further up. As a result, the sea level here will change. It is a simplistic sketch.